Hey, this is OXDF, and today we're looking at the Advent of Code 2022, Day 10, Cathode-Ray Tube. There's a very long and complicated story here, but we're basically going to be dealing with a set of, our input's going to be a set of computer instructions line by line. And there's only two instructions. There's a noop, which takes one cycle and does nothing, and there's an add vector, which takes two cycles to complete. And after two cycles, the single register in our computer is increased by the value v, which can be negative. So we're going to be tasked with keeping track of our single register as well as where we are in the cycles. So let's see. So, and it's worth saying, so they give these examples on a noop. It starts, x starts as 1, which is what x starts as. At the end of the cycle, x is still 1. Then we have this add 3. At the start of the second cycle, x, you begin add 3, x is still 1. At the start of the third cycle, x is still 1. We're still doing add 3. But at the end of that cycle, x goes to 4. So we're supposed to look at what they call the signal strength, and that is the number, the cycle number multiplied by the value of the x register. And so during the 20th cycle, the 20th and every 40 cycles after that. And so those are the signal strengths. And so it's important, they really highlight here the word during, because we got to remember that like an add instruction takes two cycles and then it changes. So if we hit 20 during one of those, we need to record it before we add. They give us a long program here. Let's scroll to the bottom. So they want to know the sum of the signal strengths during the 20, 60, what's that, up to 220, and that is our result. So let's get over here. We'll use my GenDay script for day 10. I got an overview of this in the first video, but basically it just pulls my input and as well as starts me a little stub. I'm going to review my instructions here. One thing I was kind of curious about is it looks like we can safely it's a little unclear whether it wants it's unclear whether it's looking for just these up to 220 or whether like would 260 count. I'm going to assume we don't hit 260 and that's just the way the input's set up. So we can either copy this list or we can just use math to figure that out. Okay, so come in here. What are we going to do? I think today is a good day to start writing a computer class. I've avoided classes so far, but like this seems like a good one, like where it might be just as fast to write this. So we'll do a def under init, and we will take lines, and we will do like self dot program equals lines. We will make self dot t, I guess, for like tick, or I guess we can call it like clock equals we're going to start at 0 or 1. I won't even, let's see, tell us. We just need to know like the 10th cycle. So the second cycle will be if we start at 1. Okay, so we'll start at 1. So we'll say clock equals 1, self dot x equals 1, because x is the register. We should definitely pass self into here. And I think that might be all we need. Now we'll make a, let's see, def run self, and that's going to be how we run the program. And then we might as well set ourselves, let's see, so def not self. So for our noop instruction, we are going to step. So we're going to increase the but we're going to increase the clock, but we need to do something. We check something each time we increase the clock. So let's actually create a function to do that. Come here, make another pass. We can then, I guess, do def add self v. I'll pass for the moment. We got to come back and fill these in, and we'll do def step self. And when we step, we're going to say self.clock plus equals 1. And then we're going to say, I guess we need to keep here a self.part1 or self, let's call it self.total sig stren equals 0. So we're going to be summing that. Okay, so now we're going to do step our clock. And then we'll say if self.clock minus 20 mod 40 equals 0. I think we need to put the parentheses like that. So if that, we will say self.total signal strength plus equals self.clock times self.x. Okay, so what we got here is basically we're saying if we're on one of these magical cycles that we care about, we're gonna total up our signal strength, and we're going to do that, and that is going to be our step function, and that's it. Then we're done. So now we come up here, and if we nop, all we're going to do is self.step. Pretty simple. If we add, we're going to self.step. I'm going to self.step again, and then we're going to self.x plus equals v. Okay, so what do we do? So now we have our thing. So now we just need our run function, which is going to be for line in self.lines. Let's see, how do we parse this? It's going to just be if line starts with noop, if line dot starts with noop, self.noop. I guess I should make that I probably should make that a double O, since that's what it is in the instructions. Then we can do elif line dot starts with add x. Now I could just basically say else because I'm assuming there's no other lines, but I'm gonna assume this computer might come back on another day, so we'll just take care of it a little bit here. So we can say what do we do? We'll say we don't need that anymore, comma. Well, we can say v equals line dot split dot the second item, make that an int like that, and we can say self dot add v. That look good. Okay, so now when we run it, hypothetically at the end we can just do self dot total signal strength and get a result. So we'll come down here and we will say comp equals computer lines, and we can get rid of all this, and we say comp dot total signal strength, and we'll give it a run. The odds I didn't make any errors feels small, but we will we'll give it a go. 0 seems wrong. So total signal strength plus equals self.clock. Are we making sure yeah, we're just stepping the clock. Let's try some prints. Let's see, are we ever getting here? Print self.clock self.x. We are not. Are we ever getting here? We are not. All right. Are we getting here? No. Okay, so the good news is we're just missing something really obvious. I'm sure you are all screaming it at the... We never ran the computer. There we go. Comp.run. Did I get rid of that print? I don't want all the prints. Yeah, okay. So we should run the computer. Here we go. Computer has no attribute lines. Oh, because I called it program. And we have a number, 12980. Let's see if that works. No, answer's too low. It's the right answer for somebody else. Good for them. Okay, so let's grab the example out, the example program here. I'm sure this is like we didn't initialize something the right way, or like we're off by a. Maybe I should put more thought into whether t really should start at 0 or not. Let's see, we have this new file ex.txt. Okay, we will save you. We don't need you anymore. Okay, 1430, not correct. Let's figure out let's print out. And now we can do print self dot x times self dot clock. And maybe we'll do self dot clock as well, so we can see what we're getting here. So at 20, we get 420. That looks right. At 60, we get 1140. 1800, 2940. Ooh, we missed. All of a sudden, we drop. That is interesting. How do we possibly be right through the 60th cycle, but wrong? Is it, well, let's see. So what if we start self.clock at 0? I wonder if we're just missing okay. So I think what happened is, and I might shorten that a little bit, but I think what happened is basically because a lot of times it's nopping, like most of the time it's nopping actually, like it's only changing on half of the ads and none of the other ones. And so I think it's easy to get off by 1 there, but that's the issue. Okay, so now we've got our working thing. We can run this. It's a little less confusing. Let's try this number here. And we're good. Okay. Awesome. All right. This seems like I'm probably gonna speed through my reading this so you don't have to watch me read. Okay. So the x is the position of our sprite, and our sprite is actually 3 wide, so it's the center of the sprite. So like if our x was 38, it would be here, and it would actually be these 3, right? So the cycles, it's going to check every cycle. It's going to move from here 1 to 40, 41 to 80, all the way up to fill. This is our screen basically, and it's going to check each cycle if the sprite is filling, if any of the 3 positions. So when it checks this position here at 1, if the sprite is in 0, 1, or 2, then it's going to be overlapping with the cycle, and then it's going to fill it it's going to fill it in, for example, as a thing. If it doesn't, it's going to leave the thing dark, and so we'll say like a dot. And so we're going to loop through all the cycles, and we're going to look and see if the sprite is on top of us, and if it is, we're going to fill it in. If it's not, we're not. So we will give that a shot. Okay, so we'll come up here, and what we're going to do is we're going to say self.pixels equals, and what are we going to make this? We're going to make this a I guess a dictionary. And so now we can do is every time we step, we have to now update the dictionary too. Let's see, we started at 0. Oh, that's because we're going to step. Okay, so we're going to add our 1 to get to the position. And now we will say self.pixels. So let's see, if self.x, that's our position, minus 1 is less than or equal to self.clock less than or equal to self.x plus 1. So basically, if the clock is within our x range, we can actually just say, we'll do that. We'll say pix equals, I wonder if we can do this in like we'll make this clear. So if that's the case, we'll do that. Else pix equals make it a space. That they used a dot, but that's fine. And then we will say self dot pixels sub I guess it's just clock. I guess the question is, should we go ahead and make it a grid now? Let's make it a grid now. So we'll say it's going to be self dot clock. This might be too much to do in one line. Let's do it here. So we'll say the row is equal to what row it's on is going to be self dot clock minus 1, because we're gonna we want to deal with, because we're gonna do mods and stuff, we want 0 to 39, not 1 to 40. So self dot clock minus 1 divided by 40. Do we actually need the minus 1? So if it's the if the 0 through 39 will all be there. Yeah, that's right. Okay, so that's the row. We'll call equals self dot clock minus 1. In fact, what we should do up here and do row equals self dot clock divided by 40. Call equals self dot clock mod 40. We can get rid of this entirely. And now we say self dot pixels of row comma call equals pix. No, we didn't put the equals pix. And so now at the end we should have self.pixels. We should be able to come here and write a def print self. And we'll do or R in range 40, because we know that size. For C in range 6, I believe. Print self dot pixels of R comma C comma end equals none. And then here we'll just do a print to get to a new line, and there's no way this is going to work right away, but we're going to give it a try. So we need to do comp dot print. Let's give this a go. See what happens. Missing a colon. Didn't like that. What do we do? Key error 60. How do we not get a 6? Something must be wrong up here. Let's see. Let's do print row call. Oh wait, key error 60, because we don't. Whoa. Oh, is there another print somewhere? I still have a print here. I don't need this print anymore. Also, I'm guessing if row equals 6, import pdb trace. No, we never hit 6. Oh, because I did this backwards. Man, sometimes, let's try row and column that way, and we get something. But it looks like our row is never. Are we really printing that many spaces? It looks like we kind of successfully worked on the first row, but then we never hit that again. Let's make sure we're not just screwing up our print somewhere or something. So we can do that, comma pix. So our logic must be off here. row, column. Let's try, what are we looking for here? So x self dot clock. Are we just getting way far away from each other here? Row, column. Whoa. We already verified that we're getting the right. We're verifying that we're doing this right because our power is still right. Our power didn't change it. Yeah, no, that's still good. Oh, I wonder if we're not supposed to be. I wonder if we're not supposed to be paying attention to this. Oh, I bet you our row number is not. Okay, so I think what we're doing here basically is the pixel doesn't know about a height. It's just sort of looking where it is vertically. So what we need to do is compare this self.clock. We need to look at not this. We need to look at call. I bet that's going to fix it. If it does, I'll explain. It did. Okay, cool. So what we're doing here basically is the pixel doesn't have any concept of vertical height. It just knows where we are. So it's effectively looking to paint the entire any column we're in. So we got an answer here. This is PBZG. We'll do it 4 times. PBZG RAZA. I don't know how this could be wrong. We got it. So let's go back here and take a look at this. So basically what we're doing is we were looking to see if the pixel and the X value were the same, but really what's happening is when we're here, for example, you know, this might be, let's see, 40, I don't know, like 50 something right here. Well, it's actually, the pixel still stays between 0 and 40. So we just need to basically check its column to see if its columns align. And we can do that by calculating the column ahead of time. So this is a neat challenge. I enjoyed this one. Hopefully you did too. I will be back with another one of these tomorrow. Oh, thanks, and talk to you then. Bye.